question I'm often asked is how to go about monitoring an unattended boiler. Now, the first thing that we need to really understand is what do people mean by unattended? So let's look at a few scenarios. So a very typical scenario that we find is that someone is simply not in a position to hear the alarms on the boiler. They're somewhere else in the factory. So by remote monitoring, we're talking about getting the alarms to someone, not necessarily a trained operator, but to someone who can hear those alarms. So that typically means installing a hardwired panel that repeats the audible and visual alarms to perhaps an engineer's workshop or production operations or to a gatehouse. The individual then who hears those alarms, it's their job simply to get hold of the engineer, usually on the telephone, let them know there's a problem with the boiler. And if they can't get hold of the engineer, to hit the emergency stop and shut the boiler down until such time as they can get the engineer. A second common scenario is a boiler that is left warm over a weekend while the site is effectively shut down. So there's nobody on site at all to respond to the alarm. The boiler is not meaningfully producing steam, it's simply producing steam in order to keep itself warm. So in that situation, we would close the crown valve, we would put the boiler into a low fire position, and we may want to reduce the working pressure of the boiler to around 20 to 30% of the normal working pressure. Now, it's important that we do keep some pressure in the boiler because come Monday morning, when we want to put the boiler back into working order, 20 to 30% is enough pressure to allow us to go straight into high fire. And believe it or not, the boiler will be back up to working pressure within about 5 minutes. So in that circumstance, the risks are relatively low. We're not producing steam, we're just keeping the boiler up to pressure. The burner can't achieve its highest input rate. So as long as the boiler's in good maintenance, there's no reason why it's going to have a catastrophic loss of water. Now, you might like to back up the boiler in that circumstance with a relatively simple messaging system that drops a text message to the duty engineer who's on call over the weekend to let them know that there's a problem. Now, the worst case situation is that isn't a terribly reliable technology. So the boiler doesn't know if the text message has got through, and it doesn't know if the engineer is 100 yards from site or 100 miles from site. So the worst case situation, the message doesn't get through, the engineer turns up on Monday morning, the boiler's stone cold, on low water, and you're going to lose half a shift or something like that while you get the boiler back up to working pressure. The other scenario, and the one that is actually quite rare, would be the situation where there are no operators on site, but also no one who's able to respond to an alarm. So no production person perhaps who's been trained simply to hit the e-stop. But the boiler is producing steam. So if the boiler is producing steam, significant quantities of steam, as if you were in full production, then we've got a very real risk of the boiler running out of water and nobody knowing. Now, in that circumstance, you would need to provide a full mimic almost of the boiler controls at some remote location. So typically this means an experienced operator sat watching the boiler remotely from a computer. And they would generally have telemetry, so they'd have trend information so they can look back at what's been happening in the last few minutes, and they would be able to see the current status of the boiler. It's important to understand with a text message that the absence of a text message does not mean that the boiler is safe. It simply means that the message, or it may mean that the boiler hasn't been able to send that message for some reason. So the cell tower's out of action or something like that. So with a true remote telemetry system, you're able to watch the boiler and see that communication has actually been lost and you're no longer getting live data from the boiler. Now, in that circumstance, if the engineer is relatively close, it may then be their job to get down to site and take over local monitoring of that boiler until such time as the communication system is resolved. Or you may have a fallback position where the boiler recognises that communication has been lost with the remote monitoring station and will actively shut itself down. The final situation is often asked for when purchasing boilers, but actually is never needed. And this is often referred to as BG01 Typical Arrangement 3. Now, a typical Arrangement 3 situation is really about the contract energy management firms monitoring assets that perhaps don't belong to you. Perhaps you pay for the steam and don't own the plant. So you're not in a position to send someone into the boiler house in order to deal with alarms. Now, in that circumstance, they will have a fully remotely monitored boiler house, so not just the boiler. A boiler that's suitable for remote monitoring doesn't have a great deal different to a boiler that isn't, just simply a little bit of communication. So it'll still have self-monitoring level controls, automatic TDS, automatic bottom blowdown, high integrity burner controls. But you will also need to loop in things such as the water treatment package. You will need to be able to actively do all the testing that an engineer should do when looking after their boiler, remotely and unattended, and be able to raise alarms and take appropriate action fully automatically. And that is, of course, extremely expensive. But if you don't have a contract energy management firm on site, you don't need to worry about those kind of things. You probably just need to train somebody from the shop floor who's in production how to deal with relatively simple situation of that it is in alarm. This is what you need to do. You need to push the big red button and you need to get on the phone to the engineer.